All right, to combine random variables, I've got two ECC credit hour courses comparisons listed below. Take a minute, pause this, and write this down. This one, the first one, we're going to call like ECC North, and the top one the bottom one we're going to call like ECC South. And keep in mind, we're going to assume that these are independent. That means that one is not affected at all by the other. So there's no overlap at all as far as if someone's taking a course in ECC North, then other people are not taking that in ECC South. The only thing to think about is I gave you this X one before. This ECC South one, this is a new one. I'm going to call it Y. And notice I'm only putting 12, 15, and 8 because just for our example, ECC South, we're going to say only offers 3 credit courses. And we're only talking about full-time students, so 12, 15, and 18 were our parameters. And the probability is given below. I'm also giving you the mean, and I'm giving you the standard deviation. So restart this in a minute when you have copied this down. Another thing that I want to do is review in the top corner, simple probability. If you were flipping a coin twice, what's the probability of getting, let's say, a heads and then a heads? So there are a lot of different ways you could do this. When you flip the coin, you could get a heads, you could get a heads, tails, you could get a tails, heads, or you could get a tails, tails. So you have a 1/4 chance of getting a heads and a heads. The math to precede that should be a half to get a head and a half to get another head. And if you multiply them, because they're independent, one is not dependent on the other, you get 1/4. So we're going to review, we need that topic or that independent idea so that we can be able to calculate the probabilities for the upcoming problems. First thing I'm going to do, and you might notice I did Evernote page 45 and 46. I kind of am remaking them on page 47. Let's say we were going to try to find S, which is X plus Y. Can we make a table for S? So instead of X or Y, I'm going to call it S. And I want the probability distribution table. So if I'm using S plus Y, I actually want to use 12 plus 12. 12 plus, actually 13 plus 12. 14 plus 12. 15 plus 12. 16 plus 12. 17 plus 12. 18 plus 12. Then I want to do 12 plus 15. I actually already have 27. 13 plus 15. 14 plus 15. I have all those. 15 plus 15. I don't have 16 plus 15. 17 plus 15. 18 plus 15. I also need 12 plus 18. 30, I have that, 31, 32, 33, so 16 plus 18 would get me 34, 17 plus 18, I need all the different combinations to make this, and that word combinations is going to come up more in the next section. To find the probability, because they're independent events, the probability of getting a 24 was made by 12 and 12. So I would take 0.25 and times it by 0.3. And that would be 0.075. 12 times, or 12 plus 13 plus 12 is 25. So I would take the 0.10 times 0.3, and that would be 0.03, I believe. Now, I think when I get to 14, it's still pretty clear that it's 0.03. 0.15. 27 was actually made up two different ways. 27 was 12, and let's see, this 15 and this 12. So 0.3 and 0.3, 0.09. It's also made by this 12 and this 15, which is 0.25 times 0.4. And that's 0.1, I believe. You have to combine them together to make for 27, would be 0.19. Take a minute and try to fill in the rest of this table. Okay, let's see if we can calculate the mean of S. And remember, that would be the sum of the, well, we're going to call it S and P. So I would need 24 times 0.075 plus 25 times plus 26 times, all the way until we get 36 times. So take a minute and do all those calculations. You should get 29.65. Now don't be mad at me, but there is a shortcut. Take a look at what the means of the other ones were independently. The mean of X and the mean of Y, 14.65 and 15. The mean of S would really be just the combination of X mean and the Y mean, 14.65 and 15. It's also called the expected value. But that is one of the formulas, that when you combine the two data tables and make it into a probability distribution table with them combined, it actually, the mean will work out to the same thing as if you just added the means of them together. Standard deviation is a little different, so let's try to calculate the standard deviation of S. And how we do that first is we find the squared value, which is the variance first. And the variance is the sum of the S value of each one. Take away the mean of S, square it, and then this whole thing. Oh no, not this whole thing. And that's multiplied by the probability of each one. And then in the end, we sum them up. That's what I was trying to get to, okay? So it would look like this. It would look like 24, take away the mean, 29.65, square it, and multiply it by 0.075. Add it to 25. Take away the mean, square it, and multiply it by 0.03. Add it to 26. Take away the mean, square it, multiply it by 0.015. And keep on going till you get the last number, which would be 36. Take away the mean, square it, multiplied by the probability. Calculate that and see what you got. I'm getting about 9.63, which would mean that my standard deviation would be square root of 9.63, or about 3.10322. Now, a shortcut to something like this would be, if you look at my standard deviations up here, that isn't going to help me get to it. But if I think about what my variance was, what's the squared value of 2.06? It is 4.2436, and my variance for y would be 2.3 squared, 5.29. If you add these up, the variance of x and the variance of y would have been 4.2436 and 5.29. About 9.53, around about. So the variances you can't just add up like you can add the means up. I'm sorry, the standard deviations you can't, but the variances you can. And then to get from, if this is the variance, then you could square root it to get what the actual standard deviation is, which is about 3.10, something like that. So these are two properties that you have to know, and we're going to talk next about subtracting variables and seeing what ends up happening. So the main idea for this one is that your new mean would be the sum of the two means, and your variance would be the sum of the two variances, not necessarily the standard deviations, but you could calculate the standard deviations afterwards.